Okay, so solving, or actually dividing polynomials using long division is very similar to the process of dividing numbers using long division. So it follows the same kind of idea. All right. So I put this as like a fifth grade recap because I think that's what I taught. That's when I was learned. That's when I learned it, at least. So the idea is with long division, right? You kind of start with how many times, right? Can 2 go into 7, right? That was typically like the question, right? We know that 2 can go into 7 3 times evenly. And then we would multiply 3 times 2 and we would get 6. Right? We would then subtract 7 minus 6 and we would bring down whatever was the difference. We would then bring down the next integer, which in this case would be 8. So now we have a new question, which is how many times can 2 go into 18? So the answer to that question would be 9, right? So 9 times 2 would be 18, and we would get 0. But we're not done because we still need to, right, finish up the rest. Bringing down 9, how many times can 2 go into 9? In this case, it's only 4. So 4 times 2 would be 8. 9 minus 8 is 1. And then we have this last one to worry about. We've got to bring down the 3. And 2 can go into 13 6 times. You get 12. Right? And you have this as a remainder, right? Because you don't have any more integers to bring down, right? And we're not going to like do it with decimals, right? So we're actually going to keep remainder. So we would say that the quotient would be 3,946 with remainder 1, right? Remainder 1. So this is kind of the process that we're going to go through in order to divide polynomials as well. We're trying to figure out how many times can the divisor, which is in this case 2, how many times can it go into the dividend, which would be the terms that are inside of the division box, right? We multiply, we subtract, we bring down, right? So the same process. It's just a little different because now we have variables, okay? But let me walk you through this first example. So we head over here, right? We're trying to divide this 4-term polynomial, 6x to the third minus 19x squared plus 16x minus 4. Divide that by the binomial x minus 2. Okay, so this would be always considered your dividend, right? So that's the term that goes inside of your division box. And on the outside, you have your divisor. The divisor is the one that does the action, right? It's the one that's trying to divide the other term. So x minus 2 would be on the outside. Okay. Now, our job is we're just going to focus on the leading term, which is x. How many times can x go into this first term, 6x to the third, right? Or another way to think about it is what times x equals 6x to the third? What can I multiply to only the x to get 6x to the third? Yeah, I would have to multiply by 6x squared, right? 6x squared times x would give me 6x to the third. Okay, so when you find out what that factor is, the next step is you're going to multiply 6x squared times x and 6x squared times negative 2. Okay, so here's what we're going to get. We'll get 6x to the third, and 6 times negative 2 would be negative 12x squared. All right, so that's the term that I get after I multiply. And what do we do after? We We're going to subtract. So let me zoom in here. we get 6x to the third minus 6x to the third, right? Obviously, that would cancel, right? But then we also have negative 19x squared minus a negative, right? So minus a negative, that's essentially positive, right? We're adding. So negative 19x squared plus 12x squared would give us negative 7x squared. Okay? And I can bring the rest of the terms down. Okay. Now what I'm looking for next is, okay, what can I multiply to x to give me negative 7x squared? Yeah, we want to multiply by negative 7x. All right, so now we're going to distribute negative 7x times x and negative 7x times negative 2. Okay, so negative 7x times x would be another negative 7x squared. Negative 7x times negative 2 would be positive 14x. And again, remember, we're subtracting the entire term. Okay, so I put it in parentheses and then we're going to subtract. So what happens? Negative 7x squared minus another negative. Well, minus a negative is the same thing as adding. So negative 7x plus 7x squared, these terms cancel. Okay, then we have 16x minus 14x. That becomes just 2x. And then we can bring down the minus 4. Okay, so now last part. What can I multiply to x to give me 2x? Yeah, positive 2, right? Positive 2. So I would want to use a plus 2 here. All right, and then we distribute 2 times x, 2 times negative 2. So 2x was just obviously 2x. 2 times negative 2 would be negative 4. All right, and again, we're subtracting the entire term. So wrap it in parentheses and then subtract. 2x minus 2x, those cancel, right? Negative 4 minus a negative 4. That's the same thing as saying negative 4 plus 4. That ends up being 0. Okay. Are there any other terms left to bring down? Yeah, there's no terms left to bring down, right? Negative 4 was the last term, our constant. And we already brought that down, right? So then the 0 here, that's our remainder, right? We have remainder 0, which is good, right? Usually if we got remainder 0, then that was great. So if I take 6x to the third minus 19x squared plus 16x minus 4, divide that by x minus 2, my quotient, right? My quotient is the expression that is right here. So this would be my solution, right? So 6x squared minus 7x plus 2 is what we would call our quotient. What do you mean? Is there any other way we can simplify? Do you mean like factor this further? No, the point of today's lesson is to do it the long method. Yeah, because you might have a hard time factoring this trinomial. I mean, not trinomial, but this 4-term polynomial, you would have a hard time factoring it. I'm not sure that you could, right? If you try to do grouping, right, I'm not sure that you could factor it in order to then just cancel. So this is why long division uh, or using long division with polynomials, sometimes it's needed because there's no way to divide it because we can't factor the other term and then just cancel it with the one at the denominator. All right. So this is the method. These are the steps. So yeah, no shortcut to long method. It is what it is. There is another method which I'll teach you on Friday, but that's called something else. All right. Any questions on our first example here? No. Okay. All right. Let's move on to another example. All right. Let's try this one out. Okay. This one's a little bit simpler. So you see we have our dividend divisor, right? So term that goes first, right? That's the one that goes inside our box or division box. So you have x squared plus 5x plus 1. And on the outside, it's being divided by x minus 3. So we start only by focusing on the leading term of the binomial and the leading term of the trinomial. What can I multiply to x to give me x squared? Yeah, it would just be x, right? So x. Once you have that term at the top, you're going to distribute. So you have x times x, which is going to be x squared, and x times negative 3, which is minus 3x. Put that in parentheses, and then you're going to subtract. So x squared minus x squared, these cancel. Then you have 5x minus a negative 3x. So 5 minus a negative 3 ends up being a positive 8x. And then we can bring down the constant plus 1. Okay. Now we're trying to figure out what can I multiply to x to give me 8x? Right? What would that be? Yeah, just 8, right? So positive 8. All right, now that we have positive 8, you're going to distribute that in both terms. Okay, so 8 times x would be 8x. 8 times negative 3 is negative 24. Okay, so we're going to subtract here. All right, so 8x minus 8x, that cancels. And then we have 1 minus negative 24. So 1 minus a negative 24 is the same thing as adding 24. So we end up with 25. Okay. Now, do I have any other term to bring down? Or is it even possible for x to go into 25? Right? What can I multiply to x to make it equal to 25? And we don't really have an answer for that. So what does that tell you about 25? What kind of name would you give 25? How would you label it? No, it's not prime. No, it's a word that we only really use. Yeah, it's a remainder, right? It's a remainder. So how do we write it as a remainder when you have a number but you're being divided by x minus 3? Well, part of your quotient is the x plus 8, right? This is part of it. So you have x plus 8. How do you write the remainder part? Well, you're going to add 25, but it's still being divided by x minus 3 because we weren't able to get x minus 3 to fit into 25. All right, so you have x plus 8 as your quotient, plus this would be your remainder right here. Right, so think of x plus 8, that's my quotient, but I have to add my remainder, which is the 25 divided by your original divisor, x minus 3. Okay, so that would be the correct way to write this out. Right? It would not be correct to write R25 or anything else because we're not just dividing a number, we're dividing by a polynomial. Right? So my original divisor must show up again in the remainder. Okay, questions on this one? Okay, let's move on. All right. Let's get to number 3. All right, remember, this is first, right? So that first one is being divided by the other one. Okay, so that tells you that's going to be my dividend. All right. Now, when you're doing long division, you need to make sure that there's every term is accounted for. So notice that we have x to the third, but then there's no x squared, there's no x. It just goes from x to the third and then it has a constant, right? Here's what we're going to need to do when something like this happens. You're going to have 8x to the third, that's your first term, right? But we need space holders for x squared and for x, okay? So what we're going to do is we're going to add some space holders by adding 0x squared, right? Since we don't have an x squared term, and we're also going to add plus 0x, okay? Because we also don't have an x term. And then at the very end, we'll use our minus 1. Okay, so we need to use space holders whenever we're missing a term. Okay, if it's not decreasing, right, in order, and there's a big jump, like x to the third all the way to a constant, we need to use the 0x squared or the 0x, right? We didn't add anything we weren't supposed to because adding by 0 never changes anything, right? So 0x squared is the same thing as 0. And if you add 0, you didn't change it at all. All it does is it makes it look different, and it's going to help us when we're doing the long division. Okay. So any questions on that part? Adding the spacers in. You're going to see why, all right? Because you're going to need to be able to subtract. At some point, you might need to subtract something that has an x squared term. And what if you don't have anything there? You're not going to line it up correctly. So the purpose of this is just to line everything up, right? So that in case an x squared term does appear, we know where to line it up. Otherwise, you know, where are you going to line up an x squared if it's not underneath x to the third or it's not underneath the constant? Okay, you'll see why, all right? So watch this. So, and then our dividend is 2x. I'm sorry, our divisor is 2x minus 1. So we want to take 2x. What do we need to multiply to 2x in order for it to equal 8x to the third? Okay, 4x, something else too? Yeah, 4x squared. There you go. You were close. All right, now we distribute. We're going to multiply. All right, so 4x squared times 2x will give us 8x to the third. This is what I'm talking about. Now look at this. 4x squared would also need to multiply to minus 1. So that's going to be minus 4x squared. Now imagine if we didn't have the space holder. You would have lined up minus 1 and you would have had negative 4x squared underneath. And you would not have been able to make that subtraction, right? Because negative 1 and negative 4x squared are not like terms. So this is why we need those space holders, okay? Just in case, all right? And then we're going to subtract. So 8x to the third minus 8x to the third, that cancels. You have 0x squared minus a negative. Well, minus a negative, again, is an addition. So 0 plus 4x squared, that'll be 4x squared. Okay, you can still bring down the space holder, bring down the rest. All right, so now we have a new goal. We want to find out what can we multiply to 2x in order for it to equal 4x squared. Yeah, this time it's just 2x, right? So we multiply by 2x, and then we're going to do that distribution. So 2x times 2x will be 4x squared. And then watch what happens this time. Same thing, right? 2x times a negative 1. That's going to give me a negative 2x, right? So having kind of foreseen that there was some spaces that were missing, having those now helps us clean this up a little bit better. So 4x squared minus 4x squared, these will cancel. 0 minus a negative. Once again, that turns it into a positive. So we have positive 2x. And then we can bring down the minus 1. So then last thing, what can we multiply to 2x in order for it to be 2x? There you go, right? Positive 1 multiplied by positive 1. So when we distribute this time, positive 1 times 2x, that's another 2x. Positive 1 times a negative 1 is a negative 1. And then we'll subtract. So 2x minus 2x, they cancel. -1 minus -1. Well, negative minus, I'm sorry, a negative and a negative, that makes a positive there. So that ends up saying -1 plus 1, which is 0. Okay. So in this time, though, we've achieved a remainder of 0, which is awesome, right? Because we don't need to write it in that kind of funky way. We can just write our quotient. So our quotient, since there is no remainder, is 4x squared plus 2x plus 1. All right. Any questions there? Okay. No questions. Let's move on. All right. So take a look here at this next one. When do you know? So for example, right, you had a polynomial that started with x to the third, but you did not have the x squared or the x term, right? You wanted to go descending power. So if you had x to the third, then you want next term to have x squared, the next term to have x to the first, and then no x. If it's missing, right? If it's not there, then you have to put those space holders in. You need to go down sequentially in order. So any polynomial, doesn't matter where you start. Let's say you had x to the fourth minus x plus 2. What are you missing? Well, you have x to the fourth and then you have x. There's 2 of them missing. You need the x to the third. And then you also need this x squared. Right? These are the ones that were missing. You didn't have a third, a power, anything to a power 3 or anything to a power 2. So those are the ones you got to fill in the gaps. Right? It just depends on the polynomial. It's not just 2. Sometimes it could just be 1. What if it was x to the fifth plus x to the fourth minus 3x squared minus 2x plus 5? Which one are you missing? There you go, right? So if that's the one you were missing, then you would just go back and replace it, right, by adding 0x to the third. And then everything else is the same. Okay. So it depends on the polynomial that is being divided, all right? That's being divided. So let's try this one, okay? Now, the other kind of unwritten rule about dividing polynomials is that the polynomial needs to be in standard form. What does standard form mean? It means that the leading term is the one that has the highest polynomial. The next term is the one that has the next highest polynomial. So in this case, take a look at the way that this one's written. It's written backwards. You have the constant, then 3x, right? X power 1, then you have x squared, then you have x to the third. Now, none of them are missing. They're all there. It's just written in the wrong order. So we would have to rearrange this and rewrite it in standard form. Okay, so 4x to the third is my leading term because it has the largest power. After that should come 5x squared. After that, 3x. And then after that, -2. Okay, and then it's being divided by this trinomial here. Okay, so needs to be in standard form, needs to be in descending order. If you have anything missing, you'll have to fill it in. In this case, luckily, we don't have anything missing. So we could go ahead and just jump right into the division without any space holders. All right, this time we're being divided by a full trinomial. All right, so it's a few extra steps because we will have to distribute to all terms. All right, so we begin with x squared, and the question is, what can I multiply to x squared to give me 4x to the third? Yeah, it looks like just 4x, right? 4x times x squared. Now we're going to distribute 4x to all three terms this time. So 4x times x squared would be 4x to the third. 4x times 2x, that's positive 8x squared. And 4x times a negative 3 would be negative 12x. All right. And then you're going to wrap everything in parentheses and subtract. So 4x to the third minus 4x to the third, these cancel. Right? That's the whole point, right? If they don't cancel, maybe you didn't find the correct term up here as part of your quotient. All right. Negative 5x squared minus 8x squared. That's going to give us negative 13x squared. And then 3x minus negative 12. So that makes that a positive 3 plus 5. I'm sorry, 3 plus 12 would be 15x. And then we subtract the 2. Okay, now we start over. All right, let's see. So now I need to find out, what can I multiply to x squared to give me negative 13x squared? What would that be? Yeah, negative 13. Okay, so negative 13, we'll multiply this one now to all three terms. And let's see where we end up. So that's going to give us negative 13x squared. Negative 13 times 2x would be negative 26x. And negative 13 times negative 3 would be positive 39. And then, of course, we subtract. So negative 13x squared minus a negative 13x squared, that cancels. 15 minus a negative, so that becomes a positive. That's addition. So 15 plus 26 is 41x. And negative 2 minus 39 would be negative 41. So from here, you can see we have quite a large remainder, right? 41x minus 41. But this entire term is my remainder, because there's no way that x squared can multiply to anything and give me 41x. Right, so we're going to treat 41x minus 41 as the entire remainder. Remember that this is the quotient, right? 4x minus 13. So we have 4x minus 13 plus, we would have 41x minus 41 all over my original divisor, right? My original divisor, which is the x squared plus 2x minus 3. Okay. So I know it looks really crazy, right? But this would represent, this is your quotient. And then this part is all your remainder right here. All right. Any questions on that one? Okay, so I'm going to go ahead and leave it off here.